Hello PLP Geometry. Welcome to the 7th video in Unit 4. So we are still in Unit 4. We are still talking about similarity in right triangles. Similarity and right triangles. I'm going to use shorthand. So to me, this is the most important lesson of the entire unit, right? This is lesson number 7, and it's on what are called trigonometric ratios. Now I'm going to call this 7A because I'm not sure how long it's going to take, but again, it's very important. And I don't want you to get overwhelmed. So this is on trigonometric ratios. Okay, so let's again recall what we've done so far with these right triangles. So the first thing you learned about right triangles was the Pythagorean theorem. And again, we did this in the last set of notes. So Pythagorean theorem, again, you have a right triangle with two sides given. You can use Pythagorean theorem to then find the third side. Okay, then we learned about special right triangles. Special right triangles. So these are a right triangle with either a 30, a 45, or 60-degree angle given, and one side, with one side. What we can do here is we can use that information to find the other two sides. Other two sides. Okay, and now we're going to learn about these trigonometric ratios. Now for shorthand, I like to call them the trig ratios. Now we're going to talk about what trigonometry is, right? Or trig ratios, whatever. But again, for using trig ratios, you have to have a right triangle with any, that word any, it's not very good, with any acute angle, with any acute angle. So with any acute angle in one side and one side, you can find the other sides. Or if you have a right triangle with two sides given, you can find an angle. So the big thing to understand with trig and trig ratios is that you can use it for any right triangle with any angle or any two sides given. So Pythagorean theorem is just sides only. Special right triangles are a side with one of those special angles. Trig ratios becomes your kind of universal guide, right? Because again, it needs any one angle and any one side or any two sides. Okay, so let's dive into our trig ratio discussion, okay? So what are trigonometric ratios? Trigonometric ratios. And again, you can call them trig ratios for short. So what trigonometric ratios do is they relate the side lengths of a right triangle I'm going to use shorthand of a right triangle to its acute angles. To its acute angles. So again, this is the one idea in geometry that relates angles and side lengths in right triangles. Now, there are three typical trig ratios that we're going to talk about. Again, I did not make these up. These were made up by someone a long time ago. Those three are sine, cosine, and tangent, if I could spell good for you. Tangent. There we go. Okay, so before I set you up, let's draw a right triangle. So here is our right triangle we're going to use. Okay. So here's the right angle. I'm going to call this right triangle X, Y, and Z. Now, it is customary that when you name a triangle with the three letters X, Y, and Z, the side opposite it can be labeled as the lowercase letter. So if X is up here at the top, this bottom side between Y and Z is lowercase x. If Y is over here on the left, then this, if angle Y is on the left, then the side XZ can be called lowercase y. And if Z is the right angle, then the hypotenuse, which is XY, can be written as lowercase z. So you'll see that as we go through. Okay, so let's talk about what we're going to do here. Now, whenever you talk about sine, cosine, tangent, you identify an angle in the triangle that you're referencing from. So we're going to identify X as that angle. That means that this angle is right there. Now, when you work with trigonometry, you have to label the three sides in the following manner. So the side opposite that angle, and notice I put the arc and then drew the arrow. This is called the opposite side, OPP. The hypotenuse is still called the hypotenuse, HYP. And then the third side, we call it the adjacent side. It is the adjacent side helping make the angle you're looking for, right? It touches, it's next to the angle you're looking for. Okay, so now, if I want to find the sine of angle X, what we would do is we would write it as SIN lowercase SIN capital X. So sine of X equals. And now by definition, the sine is the opposite leg over the hypotenuse. So in this case, from angle X perspective, lowercase x is the opposite side, and the hypotenuse is z. And this proportion, x over z, is what sine of x represents. Again, we're just relating our angle measures to our side lengths. One angle, two sides. Okay, the cosine of angle x. So again, we'll use lowercase cos for cosine. So the cosine of x. By definition, cosine is going to be the adjacent leg over the hypotenuse. So in this case, the adjacent leg to x is the lowercase y, and then the hypotenuse is still z. So that ratio is cosine. And then last, you have this thing called tangent. The tangent of angle x. And again, we use lowercase letters t, a, n. So tangent, capital X equals, and tangent is defined as the opposite leg over the adjacent leg. Opposite over adjacent. And that is going to be opposite leg X over adjacent leg Y. And these are the three trig ratios for X for angle X in this picture. Now, there is a mnemonic device to help you remember these ideas. And again, I'll give you a picture. The Ohio State test reference sheet has these trig ratios given to you, so I'll let you have that for your test. And I'll give you a copy as well when I give you the when we do our little mini lesson. But SOHCAHTOA, SOHCAHTOA. And again, what this mnemonic device stands for is sine opposite hypotenuse, which is the ratio, cosine adjacent hypotenuse, which is the ratio, and tangent opposite adjacent, which is the ratio. Okay. Now, let's use the same exact picture, but now let's talk about angle Y. And let's compare angle Y to angle X. So I'm going to redraw this triangle. I'm going to erase all this and redraw this triangle. Let me drag this back down here. Okay, so let's erase all this. Okay, so let me redraw the triangle. I'll draw it in purple this time. So here's our triangle, same exact triangle as before. Angle X was here, angle Y, angle Z is our right angle. Again, opposite sides are lowercase x, y, and lowercase z. So now I want to find the three trig ratios with regard to y. So now this time I'm going to circle the y, and I'll put an arc inside its angle and draw that arrow. Now the lowercase y is the opposite side, z is still the hypotenuse, but now x is the adjacent. So notice that when we change the angle referencing, the opposite and adjacent switch. That's an important idea when we make this connection between angle x and angle y. Okay, so let's find the sine of y. Remember that sine, so, is opposite over hypotenuse. So that would be opposite y over hypotenuse z. The cosine, lowercase cos, of y equals, by definition, the adjacent over the hypotenuse. And again, that's going to be, in this case, x over z, lowercase x over lowercase z. And then the tangent, tan of y, is equal to the opposite over the adjacent. And in this picture, that would be y over x. And there are the three trig ratios for y, angle y, in this picture. Now, something very important to make aware, right? I'll put asterisks. So if we look back up at x, right? The sine of x was x over z, opposite over adjacent, or opposite over hypotenuse. But x over z is the cosine of y. So in any right triangle, the sine of x equals the cosine of y. And again, in this picture, they equaled x over z. And I'll finish it. And the cosine of x, which if you look above in your notes, the cosine of x was y over z, is the same thing as the sine of y. And again, it's y over z. Okay. In the right triangle, x and y are complementary because they add to 90 degrees. So in the right triangle, angle x, the measure of angle x plus the measure of angle y, the measure of angle x plus the measure of angle y equals 90 degrees. That makes them complementary. Complementary. The state test wants you to remember that for any pair of complementary angles, the sine of one of those angles equals the cosine of the other, and vice versa. Okay, so this was the background of trigonometric ratios. So now in the next video, we're going to use them to solve some problems. So continue on to watch video B.